Okay, this is 2014 36 through 40. 36 is E, 37 is E, 38 is C, 39 is D, and 40 is A. So as always, you only need to watch the ones that you need help with or didn't get right. Okay, so first one here, we have two different populations. So one for each of the type of coupon. So the $5 off versus the 10% off. And they want to know basically the proportion that were used. So they send it out to 500 customers. What proportion of those customers actually use the coupon? So we don't want anything for a mean. We don't want one sample because we have those two populations for each of the two coupons. This is not a slope. We're not doing any before or after or anything like that. So the only option that fits here is E, the two sample for proportions. Okay, looking at 37 then. So initially they used alpha of 0.05, and they're saying, okay, what would happen if I switch to an alpha of 0.01? So what we have to think about is that alpha is decreasing, alpha is going down. And we want to know how or if that would affect the probability of a type 2 error. So the probability of a type 2 error is beta. Our connection between alpha and beta is power. Okay. So we know that power is equal to 1 minus beta, or beta is equal to power minus 1. So basically the two change together. The two have to equal 1 together. So if power goes up, I know beta goes down. If beta goes up, I know power goes down. So I know how alpha affects power, and I know how power affects beta. So we kind of need that step in the middle. So all that to say, if alpha goes down, we know that one way to increase power is to increase alpha. So if I decrease alpha, that means power is going to decrease. So if the power decreases, that means beta has to increase. They are opposite of each other. Okay, so when we look at the options here, so we have to talk about power decreasing and beta increasing. So the only one that mentions that, so beta, right, probability of a type 2 error, this is just beta would increase and the power would decrease. So E is the only choice that fits. Okay, next one, talking about the difference between an observational study and an experiment. The only difference is whether or not treatments are imposed. So we're just looking for the option that tells us something about that. So looking at C, so treatments are not randomly assigned, right? You can't actually do anything in an observational study other than what people or objects would already do, or data that has already been taken, something like that. Okay, looking at 39 here. So they're telling us to use an alpha of 0.05, which best describes the conclusion. Well, if I'm going to describe a conclusion and say whether or not I have convincing evidence, the only thing I need to look at is the p-value, which here's my p-value. Okay, it's bigger than the alpha that they give me, so I know that there is not convincing evidence. So these first three that talk about there is convincing evidence, those would be out. So D, there is not convincing evidence. So that one looks good to me. Looking at E then, so it says the t-test cannot be used for sample sizes this small. If you're tempted to pick that one, they say here after convincing themselves that the assumptions were reasonable, that means they're saying the conditions were met. So probably, even though these sample sizes are small, when they looked at them, they must have been, roughly symmetric and no outliers. So the conditions were satisfied. Last one here then. So we're asking 1,000 adults a question, and we're finding X bar, which is the average number of times people go to the grocery store in a week. And we want to use that to estimate mu, which would be for the whole population. So when we're talking about unbiased estimator is essentially saying that if I did this many, many times and I put all those X bars together, would the middle of those X bars fall on mu? Okay, so we talked about this like, if I end up with here's all of my X bars together, is the center of all those X bars actually mu? Or is mu actually somewhere over here or somewhere here? Okay, so if it's unbiased, mu is right at the center. Okay, and here we have randomly selected. This seems like a good setup. There's no reason for us to think that mu wouldn't be right in the center of all of the X bars. They're asking a sample of 1,000. That's a really good size. So we would kind of cross off anything that says no, right? There's no reason for us to think this is biased. So when we look at the rest of them here, so yeah, we just want to go with A where it actually talks about what it means to be biased. So the mean of the sample mean x bar is equal to the population mean mu. So that's referring to this formula. The mu of x bar is equal to mu.